or high impedance 1 mega ohm output impedance. Okay, so since I'm missing the head anyway, I cannot restore it back to the original condition, so I have to make it a little bit better in order to be able to actually use it in the shack, because in this configuration it's not very usable, and you have to take care of that if you're trying to get one of these units to do actual work in the shack. It's not very useful because the output impedance changes as you change the attenuator setting. Now, one last thing I want to mention is here in the actual unit, and the thing is that according to the datasheet, the vacuum tube voltmeter reads only the top scale from 0 to 10 volts. Okay, it reads that scale, and then you use the middle scale and the bottom scale if you're actually using the attenuator settings. So if you set the attenuator to 5 volts, then you use the center scale, the middle scale, and when you set the attenuator to 2.5 volts, then you use the lower scale. So what I want to do now is to show you the circuit that I have come up with in order to use this unit as originally would be expected, but with a local head, and at the same time make it better, and I will explain below. But first let me show you the circuit, the actual circuit, and I think I have a better picture here. Yeah, here it is. So here's the circuit, the actual circuit I have come up with, and this circuit is basically inside the head. Okay, the unit does need some modifications if you're going to use this circuit. One thing that it's clearly noticeable is that the unit, the 190 signal generator, is actually two instruments into one. It's actually an ALC based VFO and a vacuum tube, an RF vacuum tube voltmeter. But you don't have the ability, if you see the schematic again, you don't have the ability to split this vacuum tube voltmeter, the detector and the vacuum tube voltmeter, from the ALC loop here. And so the schematic I have drawn here actually does exactly this. Now, this portion here is the original schematic of the Tektronix, the original detector of the Tektronix that samples some signal out of the generator. Now, notice that I don't have any attenuator network here, and the reason for that is that I have decided to include external pads, external attenuator pads, or external loading resistors in order to set the output impedance and attenuation of the unit to predefined values, such as 50 ohms or 1 mega ohms that I'm basically interested in order for the measurements to have some meaning. And at the same time, I wanted to use the actual meter, the needle meter of the unit, in order to do these measurements. So the calibration scale on the meter had to be compatible with the original circuit, and so I have used exactly the original circuit here and sampled the output of the VFO before any attenuation. Okay, now if this is if I load down the VFO with external attenuators 50 ohm, I don't know, I'm not really sure at this point that the drop in the VFO voltage will be able to cope with the ALC of this circuit here, and will be able to drive the ALC and then again stabilize the output of the oscillator at 50 ohms. So this is something that I have to find out as I go through this circuit and load down with a lower impedance value and 50 ohm the whole circuit, the VFO. But anyway, here we go. Here's the original Tektronix RF detector, which is connected on this port directly into the R40 and R41 and the rest of the vacuum tube voltmeter. And notice here that we have a switch at this point, which we select between the ALC or the vacuum tube voltmeter. And notice that we have two output plugs here. One is the RF output of the VFO, and another one is the vacuum tube voltmeter, which is an input here. So in that way, what I'm trying to do is to separate the output of the oscillator, the VFO, and separate the vacuum tube voltmeter. So when I switch this switch from the ALC to the vacuum tube voltmeter position, what I'm actually doing is bringing this signal here from these diodes directly to the vacuum tube voltmeter, and at the same time I'm cutting off this line here, so I don't monitor the output of the VFO anymore. Okay, so I split these two. I can use it either as a VFO without monitoring any output, without any ALC action. And the only way that I can set the output amplitude is this potentiometer to the value I want. And on the other hand, I have an RF input directly to the vacuum tube voltmeter. Now, why is this important and why I decided to do this? Well, the reason is that if you have an RF generator and then RF vacuum tube voltmeter, you can do many different things, and one of them, for example, is you can easily pick filters, and because this is an RF generator that it's variable in frequency and in a big range, you can pick any filter from 350 kilohertz all the way up to 50 megahertz, and that's a really useful thing to do. You can use the needle of the meter to see the peaking action and the response of the filter. So essentially, you have given a new feature to the simple generator, and you can use it now as a unit that can be used to pick different filters without the need of a spectrum analyzer. So that's a really great feature to have out of this unit by just modifying here the RF head. Now, there's a problem with that, and the actual problem is that if you clearly see here, if you carefully see here, the output of these diodes doesn't go directly into the vacuum tube voltmeter, but it also goes to the ALC loop. So the problem, that the way I have done it is that let me put this up there so we can see both circuits. And the problem with that method here that I have followed is that when you try to pick your filters, you will generally manually sweep through this port out to your filter, and then back to the vacuum tube voltmeter RF input, and the switch will be in that position, and you will feed the signal back into the detector and back to the vacuum tube voltmeter. But if this ALC signal here is present at this point, then as you bring the generator signal closer to the filter, you will receive more signal out of this port, and more signal out of this port will result in more DC voltage out of here, and more DC voltage out of here will bring more DC voltage at this point, and the ALC will try to equalize this and the action of the ALC will bring the oscillator signal level back, will bring it down. So I doubt you will see any peaking action of the filter because of this